Now that we know all about slope and graphing, we're going to look at different formats of slope, with this video focusing on if you're given a table of values. So we're coming from learning about slope from a graph, and to do that we picked 2 points and counted the actual change in y, or your rise, compared to the change in x, or your run. So we're going to look at how would that change if you didn't have a graph but a table of values instead. So let's start with a quick recap on graphs. Again, you pick 2 points. So let's say I pick this one and this one. I'm going to count the change in y, so I'm moving up 2, and my change in x, which is over 3. So I know my slope would be 2/3. Now, to help us see the connection between a graph and a table, let's actually pick out some of these same points. So let's maybe do 2 to the left of the origin, and then 2 to the right. So if we start with this point, that would be listed as -6, -2. Then we move to -3 and 0, since it's not moving up or down at all. 0, 2, looks like 3 and 4. And then finally the last one would be 6 and 6. So can we still somehow get a slope of 2/3 looking at this particular table? Well, this table definitely has some patterns. We see that each time as you move to the right, the x value is increasing by 3 each time. And hopefully you can also see that my y value is increasing by 2 each time. So if we think about where to get the slope of 2/3, we have the 2 here and the 3 here. What we're doing when we move to the right in this graph, how your x's are changing would be your change in x. So since my x is increasing by 3 each time, that change in x would be 3. And then my change in y here would be 2. So the trickiest part about this is remembering to flip it, since your slope is the change in y over the change in x. So this number actually comes at the top, and then the change in x would be your denominator. So let's look at some different examples, starting with a table. So we saw that even when you have a table of values, it's still all about how your y values are changing or how your x values are changing. So one thing that I like to do to help myself remember that your change in y actually goes on top is to look at that change first. So in this table, I would focus here on my change in y's, and see that as I'm moving from 5 to 3, I'm actually dropping by 2. So my change in y here would be -2. And by doing that first, it helps me remember to put that in my numerator. Then I can look at my change in x, and here it is increasing by 3. So my change in x is a +3. So again, I just like to do my change in y first, since that's the first number that you use in your slope. So if we look at this next table, I'm going to start the same way. So my change in y here would be increasing by 3, but then all of a sudden it changes to 2 and then 4. Before we panic, let's look at my change in x, because slope isn't just one, it's the relationship between the two. So my change in x here would be increasing by 6, then only by 4, and then by 8. So if we look at that relationship of change in y over change in x, I have 3/6 first, then 2/4, and then 4/8. So why it's okay that those numbers are actually different is because if we look, those are all equivalent, and they all simplify to 1/2. So moral of the story, don't panic if you think they're different. They'll probably simplify to the same thing. So just keep going and remember to look at it as change in y over change in x. So let's go through a few more examples. If you have a horizontal table like this, can I still recommend looking at your change in y first, just to help you remember that that's the value that goes in your numerator. So from -9 to -6, that's increasing by 3. This is one where it's the same every time, which is nice. So 3 over my change in x here, which looks like increasing by 4. So this table would have a slope of 3/4. Then in this next table, again, starting with my change in y, it's not changing at all. So my change in y would be 0, which is okay. And my change in x here looks like it's increasing by 2. So my slope would be 0 over 2, but 0 over anything would just be a slope of 0. And then one more here, my change in y, those are big numbers. So if you're ever not sure and can't see it right away, you can always work backwards and subtract. So you might want to do something like 35 minus 14, and then I can see that's increasing by 21. Same thing from 49 to 35, that's increasing by 14. And then from 70 to 49 is back up to 21. So I have a combo of 21 or 14. I'm going to wait for my change in x to see what's happening here. X here is increasing by 3, then only by 2, and then back to 3. So 21 over 3 and 14 over 2. So I can see that those simplify all to 7 over 1, or just 7. So the biggest mistake I tend to see students make is forgetting that your change in y goes first. So remember, I recommend starting there and then doing your change in x. Good luck.